Hi, today we're looking at section 5-9, slopes of parallel and perpendicular lines. Take something out to write on, pause the video at any time to take your notes, and complete the check it out problems on the worksheets. We have two learning targets today. The first, I can identify and graph parallel and perpendicular lines, and then I can write equations to describe lines that are parallel or perpendicular to a given line. Here we have a little story problem. To sell a particular farmer's market for a year, there's a $100 membership fee. Then you pay $3 for each hour that you sell at the market. However, if you're a member the previous year, your membership fee is reduced to $50. So we graph these two equations, these two functions. What does a red line represent? This represents new members. And the blue line represents our previous members. They have a lower membership fee, but they all have the same hourly rate. $3 an hour they have to pay, so their slopes are the same. These two lines we just looked at are called parallel lines. The slopes are the same, but their y-intercepts are different. And so parallel lines again have the same slope, different y-intercepts. When we have vertical lines, all vertical lines are parallel because they all have an undefined slope. So in this example, we want to identify which lines are parallel. So all we're looking at is our slope. We have a slope of 5 over 3, and a slope of 5 over 3. Different y-intercepts, therefore A and C are parallel. Here we have a slope of 1 and a slope of 1, so B and D are parallel. This example, we can find the slope here of 2, which is different than we have a slope here of -2/3. But these aren't in slope intercept, or this one's in point slope. So here we have a slope of 3, which doesn't match up to anything. Let's do it different. So now we need to solve this one in slope intercept form. Okay, so solving C, or rewriting C in slope intercept form, we see here that our slope is a -2/3, which matches this one here. So therefore, B and C are parallel. Now it's your turn. Go ahead and write these all in slope intercept form. Actually, they all are. X equals 1, that's going to be a vertical line. Y equals -4 is a horizontal line. Here's another check it out. This one we know the slope. Rewrite B in slope intercept form. Solve this for Y. Good luck. Now we have a geometry application. We want to show that parallelogram, or that JKLM is a parallelogram. To be a parallelogram, that means both pairs of opposite sides are parallel. So we'll find the slopes of the opposite sides. Okay, so you notice that JK and ML are horizontal lines, so they both have a slope of 0. So we know that those two sides are parallel. Now let's look at LM and KL, or JM and KL. The slope of JM, change in Y with a change in X, we get a slope of 4. Slope of KL is also a slope of 4, so we know that those two lines are parallel. So we have opposite sides are parallel, so therefore JKLM is a parallelogram. Now it's your turn. Plot the points up there and find the slope of the opposite sides. If they're the same, then it's a parallelogram. Now perpendicular lines. Those are lines that intersect and form a right angle. So think about the corners. When the wall and the floor come together, those are perpendicular. So for a graph, you're graphing it. The slopes here are what we call negative reciprocals. If we multiply -2/3 by 3/2, we'll get a product of -1. When we have a horizontal line, perpendicular line is going to be vertical, or vertical line will have a horizontal line, and that again is always the case. Helpful hint, we talk about reciprocals. Opposite reciprocals are perpendicular. 2/3, the opposite reciprocal would be -3/2. 1/5 would be a -5. And -7, the opposite reciprocal would be 1/7. So you're just flipping the number and changing the sign. So for this example, we want to identify which are perpendicular. This A has a slope of 0, it's a horizontal line. This has an undefined slope. This has a slope of 3, and this has a slope of negative 1/3. So looking at these, we're looking for ones that are negative opposite reciprocals. So we have C and D are perpendicular, and because we have a horizontal line and a vertical line, those are also perpendicular. So we have two pairs of perpendicular lines. For your check it outs, do the check it out. And now we're on to example 4, a geometry application. I want to show that triangle ABC is a right triangle. So we're looking for a 90-degree angle or for two sides to be perpendicular. So finding the slopes of all the sides, slope of this segment AB, is 2/3. The slope of segment BC for that side is 5. And the slope of AC, this side here, is -3/2. These two are opposite reciprocals, so therefore it is a right triangle. ABC is a right triangle, and the right angle is here at that corner. Now it's your turn. You want to show that that triangle is also a right triangle. Now we're going to write an equation in slope-intercept form for the line that passes through the point 410 and is parallel to the line described by y equals 3x plus 8. So here's the line that we're starting with. We want to be parallel, which means our slopes have to be the same. So our parallel slope, and these two bars here imply parallel. So our parallel slope is 3. It's the same as the slope here. Our point it has to pass through is 410. Perfect setup for our point slope form. So we get y minus 10 equals our slope times 3 minus x. But it's asking for slope-intercept form, so we take this equation, solve it for y, distribute the 3 to every term, it gives us 3x minus 12, add 10 to both sides, and we get y equals 3x minus 2. Now let's write an equation again in slope-intercept form, which goes through this point, but it's going to be perpendicular to this line. So we start with our equation, y equals 2x minus 5 for the line. Now the slope that's going to be perpendicular to it is going to be the opposite reciprocal, or -1/2. And that's this symbol here means perpendicular, so our perpendicular slope. We have our point ready to plug it into point slope form. So our y coordinate's -1 goes here, our slope is here, and our x coordinate of 2 is there. But again, slope-intercept form, we want to write it in. So we get y plus 1 equals -1/2 times x minus 2. Solving for y, distribute the 1/2, add 1 to both sides, and we get y equals -1/2 x. And now it's your turn to write an equation that's parallel to that line, and then an equation that's perpendicular to this line for b. So to sum 5, 9 up, we need to know the slope of the lines in order to determine if they're parallel, which means the same slopes are the same, or perpendicular, the opposite reciprocals. So if one slope is m, opposite reciprocal would be -1/m. And if the slopes are neither the same or opposite reciprocals, then they're neither parallel nor perpendicular. Always rewrite your equation slope-intercept form or point slope so you can compare the slopes. That's what you're looking for. And remember, if the slope of a horizontal line is 0 and the slope of a vertical line is undefined. Good luck, and bring any questions to class.